Hello everyone and welcome back to Post Network Academy. I am Bindeshwar and today we are going to dive into an exciting topic in natural language processing, that is text classification using bag of words and a naive classifier. Text is everywhere. Movie reviews, social media posts, emails and news articles. But raw text is unstructured. Machines cannot directly understand it the way humans do. So the question is, how can we teach a machine to read and categorize text? This is where text classification comes in. Text classification is the process of automatically assigning categories or labels to text. For example, an email can be labeled as spam or not spam. A product review can be labeled as positive or negative. A news article can be labeled as politics, sports, or technology. In today's session, we will focus on sentiment analysis of movie reviews. We will start with the bag of words model to convert text into numbers and then apply the naive Bayes classifier to predict whether a review is positive or negative. And by the end of this session, you will understand how raw text can be transformed into numerical features, how bag of words works step by step, how naive uses probability to make classification decisions, and finally how Python implement this entire process with just a few lines of code. So without further delay, let's get started. So processing and understanding text allows extraction of meaningful information from raw data. And text can be structured into features that machine learning algorithms can analyze. And machine learning approaches include supervised, unsupervised, and deep learning techniques. These are very popular techniques. Now, AI models combine data and algorithms to identify patterns and generate actionable insights. So, you can understand this statement very easily. Now, see that when we talk about text classification and categorization, so text classification organizes documents into predefined categories automatically, and each document is represented by features derived from its words or phrases. Applications like spam filtering, sentiment analysis, news or topic categorization. These are application of text classification or categorization. And effective classification relies on sufficient label data to train predictive models. What is the meaning of supervised? So documents have labels, like in case of spam and not spam. Unsupervised supervised document grouped by similarity without labels. Document classification is a general problem applicable to many use cases. Practical example, let us see. So consider document as a sequence of sentences or paragraphs. Our task classify each document into categories. This involves pre-processing text, extracting features, training a classification model, evaluating performance. Let us understand concept of text classification that represent documents as features. It may be word, phrases or embedding. Use these features to assign documents to predefined categories. For example, spam detection, sentiment analysis, topic categorization. Now this is the process, and these are the steps to follow: pre-processing, feature extraction, and classification. Now let us see the complete diagram. So you will have input diagrams, thereafter pre-processing like cleaning, tokenization, lemmatization, thereafter feature extraction. We can use either bag of words or TF IDF, term frequency, inverse document frequency, or embedding, advanced techniques. Classification model, support vector machine or nav based or neural network you can use, and predicted category would be spam, not spam if it is spam related data, or movie sentiment analysis like positive or negative. So what are features? So basically features are unique, measurable attributes or properties of text data. They can be absolute numeric values or categorical indicators. It may be both. So feature represents text document in a structured form for ML algorithms, that means machine learning algorithm. For example, words, phrases, or even TF-IDF scores. Feature extraction, process of converting raw text into structured features. Usually what happens, it involves transferring documents into numerical vectors, and it helps machine learning algorithms detect patterns and make predictions. What are challenges? Finding the best way to represent unstructured text. So a standard model to represent documents numerically, and each document is represented as a vector of terms, and terms can be words, tokens, or other features. So vector space enables algorithm to process and compare documents, and we will see how. Suppose there are n distinct words across all the documents, and each document D can be represented as D, W1D, W2D till WND, and where WID, weight of word I in document D. So this is the telling word I means second word in document D, and weight can be frequency, average occurrence, or term frequency, inverse document frequency. Let us see common feature extraction models, bag of words that we will use: TF-IDF, term frequency, and inverse document frequency. Advanced word vectorization models like word to wake, glow, bird, bird embeddings. Now let us see an example. We are taking 10 sentences and with classes like positive reviews and negative reviews. So positive reviews, there are 5 sentences like I absolutely loved this movie, I loved the story and the characters. The same way there are 5 examples. And negative reviews, like I hated this film, it was boring and too long, like this one. So 5 negative and 5 positive. Now let us see convert into bag of words vector. So here in first sentence, loved was 2 times, movie was 1 time, the same other word absent. So we have converted text or sentence into vector. Here last column shows the class or label, positive or negative. So basically use of word bag of words is used in classification. And here positive words like loved, fantastic, great, excellent, other like is, the, these are repeatedly, they don't affect on the classification. So these are most important words, you can say that. For negative words, boring, terrible, worst, hated, poor, and word appearing multiple times indicate stronger sentiment, loved twice. Machine learning algorithms learn these patterns from training data and thereafter they predict. New unseen reviews can be classified as positive or negative. So Naive Bayes is a probabilistic classifier based on Naive Bayes theorem, and that assumes conditional independence between features. So in Naive Bayes, two features are independent. Let X, and there are 10 features, to be the bag of words vector of a review, and Y, that is level, either it is positive or negative, be the class level. And formula for predicting P Y given X, here that is the class probability and that is the likelihood, and the denominator, this is in all expressions, this is in all, means this is common for all, so it does not affect anything on the probability of a class. So here, since Px is a constant for all classes, so we will not take here, just y hat, this part, probability of y class, y or class, you can say that in this way, and the frequency would be, you can say that power of probability of xi given y. There are 10 features, so I from 1 to 10. Now here Py prior probability of class y, P xi given y likelihood of words xi in class y. These two are very important. Now we have taken 10 sentences for training and one review we will test using the trend model. So here loved one, you can see that x1 movie, x2 fantastic, x3 boring, x4. So these are features. One word is feature in bag of word representation. Terrible, x5, great, x6, excellent, x7, worst, x8, acting, x9, story, x10. Now if we count the word loved appears 2 times, movie appears 1 time, story appears 1 time, and all other words in vocabulary, that is 0. So bag of word vector representation is 2 1, other 0, in the last 1, because story appears 1 time. Positive word counts, so you can see that loved has come 2 times, movie 3, story 2, great 2, excellent, acting. We are talking about some from all positive reviews, not only one. Thereafter, total words in positive reviews 11. So Px1 is equal to 2 given positive. That would be 2 upon 11. And that probability would be 0.128. Similarly, we can find out for x is equal to 2, that is 3 upon 11, and x10, that is 2 upon 11. So that is for loved, that is for a movie, and that is for story. Now here joint probability for a review one. This has come two times. This has come one time. So why two? Because you will you can say that write this one if any word appears two times, so power would be 2, three times power would be 3. Now we will multiply all, so we will get this value. This is not probability but just proportional to probability that can be converted into probability. Now so multiply by prior, so prior is here, that means class probability. So half examples are of positive and half are of negative, so that is py 0.5. Now for a negative one, negative word counts. See that loved 0 times, movie 3, story 0 times, fantastic, great, these are absent. Acting 1, boring, terrible, worst. These are many times for a negative sentiment. Now the same way we will calculate here. The probability is here 0 because it has come 0 times. This one x2, that is movie 3 times, and x10, that is story, that is also 0. So joint probability for review 1, so because this is 0, this one is 0, so if you multiply, so that would be 0. Now P negative sentiment, that would be 0. You can see that positive given x is greater than positive negative given x. So we can say that review 1 is classified as positive. Now let us see Python code. So here complete code, numpy library is extracted from sklearn feature extraction for a text, and that is a count vectorizer, that is basically bag of words you can compare with, and multinomial nav-based library will import from sklearn, and now because multinomial we will require because there are more than one feature in pipeline. So here positive reviews, negative reviews, thereafter training positive plus negative reviews, train thereafter negative also, and here vocabulary there are 10, thereafter vectorizer will pass, will also you can say that initialize and classifier object, thereafter we will put in the pipeline, finally here will train the model xtrain and ytrain. These data will require and we have extracted here. Bag of word matrix we can plot here, thereafter matrix, and thereafter review will see. So model, what will model predict? So test review 1, after we will get the probabilities, predict probabilities, and finally we will get the classification result. So let us see without running a program, it would be difficult to understand, might be. See that here. These are vocabulary. This is the matrix, and this one is test review. This sentence will test. So probability if you get, so 0.9337 and this is 0.0663. This is, see that this is probability, and I was finding out proportions. So proportions can also be converted into probability. Now hope you understood, and for a more resources you can visit website www.postnetwork.co, YouTube channel, Facebook page, LinkedIn page, GitHub repositories. So hope you understood. Thanks for watching the video.